Hi, I am Syed Muhammad Fawwaz bin Syed Azhar from 1TSC. Now, I'm going to show you about this slide with Ameer Khalid bin Muhammad alias. How to prepare data format. First, you have to access the data. And the second, fetch the data. Third, cleanse the data. Fourth, format the data. Fifth, combine the data. And then lastly is analyze the data. Now we are on third slide. How data being divided. First, the process of dividing data is called as a packet segmentation. Packet segmentation happens at layer 4 of the OSI models. Protocols that perform packet segmentation at the source usually include automatic repeat request ARQ mechanism at the destination to reverse the process and reassemble the original packet from individual segments and request the source to retransmit the missing statement. In a communication system based on layered OSI models, packet segmentation may be responsible for splitting one MPDU. MPDU is stand for Media Access Control Protocol Data Unit. MPDU is a message that is exchanged between Media Access Control (MAC) entities in a communication system based on the layered OSI models. It's splitting one MBDU into multiple physical layer service data units so that reliable transmission of each one can be performed individually. The ITU-TG has an standard which provides a way to create high speed up to 1 GB per second local area network using existing home wiring such as power line, phone line, and coaxial cables. Is an example of protocol that employs packet segmentation to increase reliability over noisy media. Next, we go to header of each layer. The header contains the sending and receiving port, a field with the length of the packet and a checksum. The sending UDP process attempts to send the packet to its peer UDP process on the receiving host. The application layer determines whether the receiving UDP process acknowledges the recipient of the packets. How header being added to each data. The packet is the basic unit of information transferred across a network consisting at a minimum of a header with the sending and receiving host addresses, and a body with the data to be transferred. As the packet travels through the protocol stack, the protocol at each layer either add or remove fields from the basic header. When a protocol on the sending host add data to the packet header, the process is called encapsulation. Moreover, each layer has a different term for the altered packet. What does segment mean? Segment is a portion of a computer network. The nature and extent of a segment depends on the nature of the network and the device or devices used to interconnect and station. And the frame is the data that is transmitted between network points as a unit, complete with addressing and necessary protocol control information. A frame is usually transmitted serial bit by bit and contains a header field and a trailer field that frame the data. Next, we go to sequence. Sequence in a network, data is sent in small quantities called packet. When packet is sent, these packets are numbered, and this numbering is called a sequence number. The reason for this sequence is that on a big network, like the internet for example, it is not guaranteed that packet will arrive in the same order than the order they were sent. Network congestion can make that some packets are sent via a route and when at some point this route is congested compared with the traffic jam. The next packet will be sent via an alternative route, so packets that got stuck in the traffic jam may arrive later than the ones after them that were routed via the alternative route. And that is where sequence number become useful. Packets are sent in order 1, 2, 3, 4, 5, 6, but they may arrive in another order 1, 2, 3, 5, 4, 6. On the receiving end, packets are stored in a buffer before handing them over to the application, and this gives the receiving system the chance to put the data back in the normal 1, 2, 3, 4, 5, 6 order by sorting them on the sequence number. And next, we go to address route. Routing is the process of selecting a path for traffic in a network between or across multiple networks. Broadly, routing is performed in many types of network, including circuit switch networks, such as the public switch telephone network (PSTN), and a computer network such as Internet. MAC address. MAC stands for Media Access Control Address. MAC is a hardware identifier that uniquely identifies each device on a network. Primarily, the manufacturer assigns it. They are often found on a device's network interface controller (NIC) card. The IP address. An IP address or Internet Protocol address is a series of numbers that identifies any device on a network. Computers use IP address to communicate with each other both over the Internet as well as on other networks.
Okay, now I want to explain about packet forwarding. Packet forwarding is the process of a networking component accepting a packet and transmitting it to its destination. For example, a router receives packets from hosts on one attached network and forwards them to hosts on another attached network or to another router for further forwarding. How packet is forwarded is based on a comparison of the packet's destination address with the routing table stored in the router. Each act of forwarding by a router is called a hop across the network. So, apa yang kita faham ialah setiap router ni dia akan beri paket kepada yang lain dan bila router tu bagi paket kepada router yang lain, ia macam hook, dia akan lompat. So, itu packet forwarding. Yang seterusnya, error control. Okay, bila kita bertemu dengan error control ni? So, while sending the data from the sender to the receiver, there is a high possibility that the data may get lost or corrupted. Error is a situation when the sender's data does not match the data at the receiver's end. So, dia tak sama dengan apa yang dihantar tu tak sama dengan apa yang diterima. When an error is detected, then we need to retransmit the data. So, there are various techniques of error control in computer networks. What is that? Apa itu error control? Error control in the data link layer is a process of detecting and retransmitting the data which has been lost or corrupted during the transmission of the data. Any reliable system must have mechanism for detecting and correcting such errors. So, kita akan ada satu sistem yang akan membantu kita detect dan membetulkan kesalahan-kesalahan ini. Error detection and correction occur at both the transport layer and the data link layer. Okay, kita ada dua types of error iaitu single bit error when there is a change in only one bit of the data senders. When the sender's data, then it is called a single bit error. Burst error when there is a change in two or more bits of the sender's data, then it is called a burst error. The next is handshake protocols involved. How handshaking is used. In order is to establish a connection between a computer and a device, a modem, printer, or server. The handshake process begins the connection by telling the devices how to communicate with each other. A classic example is the noise made when two dial-up modems connect to each other. So kita akan tahu bila diorang ni lakukan handshake, dia akan berbunyi antara satu sama lain. Itu contoh yang lama. Tapi contoh yang sekarang ni, A handshake can also be used between a computer and a printer before printing and the express to tell the printer how to receive and output the data it received from the computer. So sekarang ni bila yang kita suruh guna ialah bila kita guna komputer dengan printer tu, rasa tak bila kita tekan print dia akan berbunyi, printer akan berbunyi. Itu contoh handshake protocol. In addition to exchanging protocol information, handshaking is often used to verify the quality or speed of the connection, as well as any authority that may be required to complete the connection between devices. This latter purpose is a common part of establishing a connection between your computer and a remote server. The next is TCP or IP. What is TCP or IP? TCP or IP stands for Transmission Control Protocol or Internet Protocol, and it is a suite of communication protocols used to connect network devices on the Internet. Is also used as a communications protocol in a private computer network. The entire IP suite, the Internet Protocol suite, a set of rules and procedures, is commonly referred to as TCP or IP. TCP and IP are two main protocols. Two others are included in the suite. The TCP or IP protocol suite functions as an abstraction layer between Internet applications and the routing and switching fabric. Next, TCP or IP specifies how the data is exchanged over the Internet by providing end-to-end communications that identify how it should be broken into packets, addressed, transmitted, routed, and received at the destination. TCP or IP requires little central management and is designed to make networks reliable with the ability to recover automatically from the failure of any device on the network. How does this work? It uses the client-server model of communication in which a user of a machine, a client, is provided a service, like say network page, by another computer, a server in the network. Next is UDP. What is UDP? UDP is a user datagram protocol operates on top of the Internet Protocol (IP) to transmit datagrams over a network. It does not require the source and destination to establish a three-way handshake before transmission takes place. Additionally, there is no need for an end-to-end connection, since UDP avoids the overhead associated with connections, error checks, and the retransmission of the missing data. Is stable for real-time or high-performance applications that don't require data verification or correction. If verification is needed, it can be performed at the application layer. UDP is commonly used for remote procedure call (RPC) applications, although RPC can also run off top of TCP. Remote procedure call (RCP) applications need to be aware they are running on UDP and must be then implement their own reliability mechanisms. So, sini ada gambar TCP and UDP. So, kita tengok. TCP, slower but reliable transfer. Tapi UDP ni fast but non-corrected transfers. Contoh TCP, email, web browsing. UDP, music streaming and voting. So, itu adalah contoh perbezaan antara UDP dan TCP. Routing. Network routing. Apa itu network routing? Network routing is the process of selecting a path across on one or more networks. The principles of routing can apply to any type of network, from telephone networks to public transportation. In packet switching networks, such as the Internet, routing selects the path for Internet Protocol IP packets to travel from their origin to their destination. These internet routing decisions are made by specialized pieces of network hardware called routers. So dia routing ni proses by which a network makes a forwarding table. Lain daripada pocket forwarding. Pocket forwarding ni process of sending a data packet through the network. Itu ni perbezaan. Subnet. A subnet or subnetwork is a network inside a network. Subnets make networks more efficient. Through subnetting, network traffic can travel a shorter distance without passing through unnecessary routers to reach its destination. So, kalau shorter distance, dia akan mempunyai shorter time to maklumat tu sampai. Traffic tu sampai. So, ambil contoh. Imagine Alice puts a letter in the mail that is addressed to Bob, who lives in the town right next to hers. For the letter to reach Bob as quickly as possible, it should be delivered right from Alice's post office to the post office in Bob's town, and then to Bob. If the letter is first sent to a post office hundreds of miles away, Alice's letter could take a longer to reach Bob. Okay, contohnya, Alice ni duduk Negeri Sembilan. So, yang Bob ni duduk Johor. So, Alice ni, subnet ni, dia macam nilai tu pergi Johor terus. So, dia tak payah pergi nilai tu pergi kat center KL, pergi ke Johor. So, kita akan ada shorter distance. Like the postal service, networks are more efficient when message travel as directly as possible. When a network receives data packets from another network, it will start and route those packets by subnet so that the packet does not take an inefficient route to their destination. So tu ada gambar dia. Subnet addresses. Subnet addressing allows an autonomous system made up of multiple networks to share the same internet address. The subnetwork capability of TCP or IP also makes it possible to divide a single network into multiple logical networks. Subnets. For example, an organization can have a single internet network address that is known to users outside the organization, yet it can configure its network internally into departmental subnets. In either case, fewer internet network addresses are required while local routing capabilities are enhanced. A standard internet protocol IP address field has two parts. Ada dua. Pertama, a network address and a local address. To make subnets possible, the local address part of an internet is divided into subnet number and host number. The subnet is identified so that the local autonomous system can route message reliably. So next, cables that the data will travel in binary. So tu contoh cables. Transferring data through a cable uses the same principle as conducting electricity along a length of metal wire. At its most simplistic, data sent over a cable is converted into binary code, a collection of 1 second and 0 second or second. The device transmitting the data will send current along the table at two different voltage. For instance, volt and 5 volt, with one voltage representing 1 second and the other 0 second. The device receiving the data will interpret data current as binary code and then convert that back into the original format the data was before it was sent. The volume and speed of processing data over a specific time frame is covered by the Internet standards. Fiber optic cables work in much the same way, but instead of transmitting electrons down a cable, distant pulses of light. Imagine turning the torch on and off. When the light is on, you are transmitting a 1, and when it's off, you are transmitting a 0. Because light travels further and faster than electrons, fiber optic cables are capable of transmitting much more data than copper cables. Because light travels faster than electricity. So yang kita guna sekarang 5G semua tu adalah fiber optic cables. Okay. Network topology. What is that? Apa yang kita tahu tentang network topology? The configuration or topology of a network is key to determining its performance. Network topology is the way a network is arranged, including the physical or logical description of how links and nodes are set up to relate to each other. So kita tengok gambar ni dulu, network topology types. Okay, there are numerous ways a network can be arranged, all with different pros and cons, and some are most useful in certain circumstances than others. So ada yang kita keadaan menggunakan topologi jenis ni, ada lagi kita menggunakan topologi jenis yang lain. Admins have a range of options when it comes to choosing a topology, and this decision must account for the size and scale of their business, its goals and budget. Several tasks go into affecting network topology management, including configuration management, visual mapping, and general performance monitoring. The key is to understand your objective and requirements to create and manage the network topology in the right way for your business. So, seorang yang handle tu, dia pilih apa yang sesuai dengan bisnes dia, apa dia punya pros and apa dia punya cons. So that is all for my presentation.